Hello, so I'm going to be taking you through this simple project just because I know some of you have had a few difficulties trying to get the back-end and front-end working with Jenkins, and in this demonstration we're going to be using Docker just because it's the easiest way I found to get the server running in a continuous integration fashion. Right, so the first thing we need to do is create a virtual machine on Google Cloud Platform. Hello Maya. So, in London, 4 GB is more than enough. The boot disk type is going to be, I'm just going to put mine to Ubuntu 18.04. Allow these. Yeah, that's fine. I've already got all my firewall settings set up for this video. If you have any difficulties with that, just come grab a trainer. So while that's loading, I'm going to take you through the brief structure. So server, it has its own Dockerfile within it, as well as a POM.xml and source. In the source, so the main file, so the com.qa, we have a controller. This is what we're going to fire our requests. This is the thing which is going to have our endpoints. This doesn't do much functionality. All it's going to do is call on the service. And our service has a get, a create, an update, and a delete. Right, that is going to call on a repository class, which is going to extend the JPA repository. It knows how to do its thing from the model, which is just in this case going to have a long ID, which is automatically generated, and some text. Ooh, bless me. We also have in here a data transfer object. Now, data transfer objects exist because sometimes you don't want to manipulate entities directly. The reason why you don't want to be passing entities back and forth between your methods is because if at any point it's not part of a transaction and it doesn't know how to update the database as part of this method, what you're going to get is known as a detached entity exception. So detached entity exception is just going to mess everything up. So if we don't want a detached entity, all we do is we create a regular object and call it, in this case, note, and call it note DTO, note data transfer object. So when we actually take information in from the front end or send it to the front end, we're actually going to be sending these data transfer objects. Now, in my case, in this project, we're going to use data transfer objects quite a lot. Realistically, when you go into much bigger projects, you're going to have mapper classes and imports which map between data transfer objects and your models directly. So let's have a quick look at the client. Inside our client side, we're going to have some public HTML space, and inside there is just my entire website. Right, let's have a look at this Dockerfile. Hopefully by now, my GCP instance is all set up. First thing we're going to do, sudo apt update. It's going to update the install list. We're then going to install Java because we're going to need it for Jenkins in just a little bit. Dum-de-dum. Finally, we have Java installed. So now let's install Maven as well. I then want to install Docker. So with Docker, you can't just do sudo apt install Docker. Even though that is an option, it won't actually install Docker. Crazy, I know. So we just find a how-to guide, and then we just follow it end to end. Okay. So again, we're just going to sudo apt update. Nope, that didn't do what I wanted. We're going to install just a bunch of different things. Right, they're installed. Let's get Docker's key, similar to how you'd install Jenkins. Okay then, so thought that'll do it. Hopefully you should know where these Docker bits and pieces are now. So when I try to install them, you should have no trouble finding how to download it. And then it's going to start downloading it. Lovely. So you might be thinking, well, what the heck is Docker? Well, hopefully you know by now what a virtual machine is, which is on the left. Virtual machine is going to contain an operating system, have a runtime system, and then have an application. Now with a container, you don't need an operating system because it's just going to run on our local operating system. This is really useful because this is a good way of showing just computer usage. On the left, including an extra operating system to run files in this containered way with the virtual machine, it's just going to take more resources. We don't need a separate operating system. We just need to run whatever we have, this runtime system and this application, on our operating system. Now these runtime systems, you'll find out later, is essentially our images, and we're going to put onto these images our application. Lots and lots of noises. Rightio. So that's what Docker is. Just more efficient virtual machines. There's lots more behind it, but for now, that will do. So all I want to do is I'm going to clone down my repository. I recommend you doing the exact same steps as I do during this demonstration, so you can fully understand what's working on your machine. So I got my simple project. Don't know why I put delete, probably remove that in a second. And what I want to do first is this doesn't look right. So do a good status. I'm actually in the master branch. I haven't pushed to master yet. I've been working in developer, so I'm just going to git checkout developer. This again. Here we can actually see we got a Jenkinsfile, we got a docker-compose, we got a client and server, which is my front end and back end. So I want to get my server set up first, and I want to have a look. So if I do quick ls, you can see we've got a Dockerfile as well as my pom.xml and source. So if you have a look at my Dockerfile, it is actually fairly small. What we're saying is from the following image. This image is just something which has Java installed on it with Maven. Okay, we're going to copy inside our target file. Our target folder is anything which has been compiled. Our notes jar. So this is what we're copying from. So we'll make this in just a little second, and then into this image up here, we're going to be pasting into the user/app. So just like how Ubuntu has a /user, this image actually has an extra folder called app. My machine doesn't, but this container does. So it's just going to find user/app and put our jar into the container inside this image. Finally, the entry point. This is essentially just a command which is going to be run when we run the image. Okay, so let's create our jar file, this jar here. If I just do Maven test on my project currently, what it's going to do, oops, sorry, not Maven test, if I try to Maven install or Maven package or anything like this, I want to package it into a jar. In the POM, in just a little second, I'll show you that the packaging is just defaulted to jar. And I'm going to try run the tests, because as part of the Maven lifecycle, it always try to run tests before Maven package or Maven install. But my tests are going to fail. And they're going to fail because, well, there's a bit of a problem here. My Selenium tests are going to try and test the front end, but they can't make the front end and it can't test the services until it's already up and running. So what I need to do is Maven test, and I'm going to tell it, sorry, Maven install, it's going to clear that way, Maven install, I'm going to tell it to skip tests. So this way it should package it all up for me and just skip all the tests. Hey, and this time you actually get a build success. So if we go into this target file, we can see that we actually have this notes jar being generated. Why? Well, let's have a look at the pom XML. Oh. So the reason why we have something called notes 001 is because my artifact ID and my version. It doesn't actually have a packaging tag here, so we can package in multiple different ways. I've just said I haven't actually specified it, so it's just going to take it as package it as a jar when I run Maven package. Right. So inside this target, I have this jar. Now, a jar is just a compiled application. So how it goes is you have, it's just our application which we can run. I can actually show you it running. If I go Java jar, notes. Hey, and look, I have my SpringBoot application just running, just through Java, ready to go. And it's actually started there. Right, lovely. Well, I'm going to use that inside my image. What I'm going to do, I'm going to take that jar. I'm actually going to put it inside this user app folder, inside this base image. Then inside this base image, I'm just going to tell it to run that file. Right then, so let's have a look with Docker how we can do that. If I were to say, hey, oh, hang on, if I clear that away. If I have a look on my directory, it can actually see a Dockerfile. So if I were to say, hey Docker, build for me the following image, and I'm just going to give it a nice little tag. Well, I'm going to give it my Docker Hub name, the project, which I'm just going to call individual project backend, and then tag it as, well, this is just going to be latest. And then I need to tell it where this Dockerfile exists. Well, it exists within the same location, so I'm just going to put a dot at the end. So what it's going to do, it's going to try and build this new image. So we're going to get a base image, and we're going to put things onto this base image to create our new image for ourselves. So if I were to do sudo docker image ls, what we have here is the image which we've just downloaded, so it doesn't have to download it again. We also have our application. What this means is that with Docker, I can now run the image I generated before. Because it's in a container, what I also need to do, I need to have it detached, and I'm going to port forward port 8081 and send it to port 8081. This is just a way of saying, hey, when my machine receives requests at port number 8081, send them to port inside the container 8081. Realistically, I didn't have to change this. I could have left it with default at 8080, but when my machine receives items at 8081, it would send it into 8080. I just changed both because it's just easier during troubleshooting. So let's run this. And what we'll see is this just running in the background now. So an instance of an image is known as a container. So because it's running that image, you can actually see that we've now got a container. because it's an instance of this image. Kill that off for now, and I'm just going to show you that running actually. I don't know why I changed it to root there. No worries. What I've done, I've just opened up a new screen because I'm pretty sure this is going to crash in a second. So I just want to be able to get back to it when it does eventually crash. Hey Docker, open port 8081 and actually run the image we just created, the image that we built before. This time I'm not going to run it detached, just so I can actually see it on my screen. Just see that inside this container, would it be working? Lovely, and would you look at that? So now that's running inside another screen. I can say, hey, if I were to go to this localhost at port 8081/note, what I get back is all of my notes. There's nothing in there yet because I've just created this, but we can see that this confirms to me that it is working. So we can shut that down, and that's fine. So let's just do a quick recap. Sudo docker image. We built this image by using the sudo docker build command. After building this image, we were able to run this image with a sudo docker run command. -d for detach, so do it in the background. -p to actually send information and port forward. Finally, you just need to give it the actual image to them, and so forth. Lovely, so that's how the server Dockerfile is working. You should be able to do the same thing with your projects. Well, inside my client, I again have a Dockerfile from httpd:2.4. This is Apache. So inside this machine, I don't actually have var/www/html. It just doesn't exist because I don't have Apache installed on this machine. What I've done is I have a container which is going to have Apache on it. And inside there, I'm going to copy everything from my public HTML, copy everything in here, and paste it into this location inside the container. Now, you might have guessed, that's quite a long extension. I didn't work that out by myself. You have to look at the documents, the documentation provided on Docker Hub to actually work out how these images need to be used. And they should be able to walk you through that. So this Docker image, let's build it. Sudo docker build. I'm going to tag it with Christoph Perrins /individual project frontend, and it's going to look for the Dockerfile at this location. So it's going to download Apache, the Apache image, as well as copy all those files, which I'll show you now. Just my index, my JavaScript, and my styles into there. So now we should actually have two images that I'm interested in, my front end and my back end. So sudo docker run. I'm going to run this detached with -p. When I receive requests at port 80, send them to port 80 within this container. And I'm going to run the following image. Individual project front end. We can see that's running in the background. I'm also going to run in the background at port 8081 Christoph Perrins individual project backend container. So I have two instances of the containers running. Sorry, two instances of images running. So I have two containers. We can verify this by going docker control list the containers. I have my backend and my front end. Okie dokie then. So this is quite magical. All you have here is my website, and it's just running. Just testing out the functionality. And we can see that this is all working fine. Don't know what that is, just going to leave that out. We can see it's actually going to this location inside my website. And it's actually getting all the requests. I was just printing them out there just to show you. That's great. So we know that these stock images are exactly built what we want. I don't know why I got that one running. Let's close that off. So these containers are working fine. However, that was a lot of steps I had to do. I don't want to have to tell people, do this, now do this, now do this, now do this. Because admittedly, it is going to be quite long having to go through this every time. To build each image, run each image, specify the image to run, tell it to go up, down, and then also delete these container IDs. It's just a bit much for me. Especially because we're going to automate this with Jenkins later. So I'm going to kill off these containers. And this is where the Docker Compose comes in. What this is going to do, it's going to automatically build all of my Dockerfile automatically for me. So let's have a look at this Docker Compose. I'm going to use version 3, that's just default. With 16.04, I think you might have a few issues. You may have to change that to 2. So I'm going to have the following services. Now, client and server are just names I've given it. Client is just going to build the image located within my client folder. See, client, and inside client, I have a Dockerfile. So it's just going to build from that Dockerfile. And we're going to expose ports 80. So we're going to, when we receive a request 80, send into the 80 port within the container. Now server, it's going to build from, it's going to build the Dockerfile located within server. And this time we're going to, every time we get a request at port 8081, send it into port 8081 within the container. Lovely, so I don't have to piddle about doing Docker build this, Docker run this, blah, 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 blah. All I need to do is install Docker Compose, because for some reason it didn't come with those packages we downloaded earlier. Lovely jubbly. So we're just going to say, hey, Docker-compose is going to, what's Docker-compose going to do? It's going to look for a docker-compose.yml file, .yml, YAML, within our current directory, within our current working directory. And what we're going to say is, hey, build. What it's going to do, it's just going to build everything it can, everything it's told to build there. So it's built all our images, just again for me. If you want me to prove that to you, there we go. Simple project delete server, simple project client. These are the two services it has just created for us. They look, if you can tell, the sizes are just the same because they are literally the same thing. Just, it's given it automatically generated names. Lovely jubbly. So after telling Docker to build it, it's going to do it again because it doesn't even harm it. After that, we're going to say, hey Docker, up, and we're going to run it detached. And again, it's going to find those services and run them. Hey, would you look at that? It's just by saying docker compose up, it's put these, it's started running those containers. And again, my website is still working. If I want to take that down, all I need to do is say, hey, come down. Now this is going to be much easier to automate pulling up and pulling down in Jenkins. Right, so that's just an introduction to Jenkins. Let's now get Jenkins all set up because we've got it all running. All we need to do is each time we just need to say, hey, docker compose build, followed by, oh bloody hell, didn't mean to do that, followed by sudo docker compose up. Each time it builds, it's going to update the images. Each time it runs this, it's going to check whether those images have been updated. If they have, it's just going to override the it's just going to redeploy them over where they're currently deployed. Right, let's get Jenkins installed then. Now again, Jenkins doesn't have just a sudo apt install. You have to go a little bit more into it. Luckily, there's lots of how-tos on how to do that. We've already installed Java. So we're going to get the key to how to download it, or where to download it, I should say. We're going to have it look inside that location when we do sudo apt update, and we're going to call it Jenkins. So that when I run sudo apt update, this time it actually knows where Jenkins is. So if I were to do sudo apt install Jenkins now, hey, would you look at that auto finish because it actually knows where to download it. So we download it. And we download it. Okay. Very cool, so that's fine. So now if we go back to that IP address, at port 8080, we should see we have Jenkins. Yep. And it's telling me, hey, onside the machine we've put a password. So what we're going to do is just paste that password in. And it's just going to download a bunch of things. Yep. Just going to sit here while this downloads. Cool. Lovely, and fashion typical of me, I'm just going to call everything admin. Just because sometimes it freaks out when you give it long names. So let's start using Jenkins. Well, I know you've been using freestyle projects, but I'm actually going to create a pipeline. It's essentially going to have a workflow. So we're going to be lots of complex things we want to be doing. Because here we can't actually see what is going on. Pipelines are just going to make it a little bit easier for me to see everything what we want to do in it. So I'm going to just call it individual project. And it's going to be a pipeline. Now I'm just going to have this policy in. Every 15 minutes or so. I just want that's how you do it. Yep, so that's going to do it every 15 minutes. So this is the current time, that's the next time. Every 15 minutes is, fairly standard. Now we're going to take our pipeline script. This is essentially how we're going to get it to build. So previously we were used to writing all of our commands here. Echo hi, Maven test, blah blah blah. Copy from this location into var www HTML and so forth. Excuse me. Well, we don't actually want to do that. Let's build a pipeline from the source control manager. And it's going to look for something called Jenkinsfile inside this Git repository. Well, I've been working with developer, and with master I'd probably want it to do continuous deployment as well as integration. So that's why I'm just going to stick to developer here, because I don't want to do continuous deployment with you guys just yet. We can see what we actually have a Jenkins file. And it's just going to do the following stages. Stage 1, we want it to build. So, what it's going to do, from this space that it's just downloaded, it's going to go into the directory server. So let's just do cd server for now. And then it's going to run maven install skip tests. The reason I wanted to do this is because this is going to create my jar file. Remember this jar file which we needed earlier? Well, that's what that first step is going to do. We're going to build it. At this stage, I can test my application just by running the JUnit tests. So sticking within the server directory, I want to do the following. Maven test, and I'm going to tell it which file I want it to test. Now, inside this, I actually have a bunch of different tests. I'm just going to copy and paste this here for now. So why have I told it to run only this individual class? Because that's what that -d test is doing. We're saying only run this specific test class inside here. Well, the reason being is that I'm testing my controllers, I'm testing my service, I'm also testing it with Selenium. Now, if I just do Maven test, it's going to try run it with everything. It's going to try run it with Selenium. But I've not deployed it yet. We still haven't actually deployed it. But I still want to test as much as I can before I deploy it. So I say, hey, this is a suite. It is going to run node controller test and then the node service test. It's just going to test those two classes. So if you look in here, we have our node controller test and the service test. And this is just going to do JUnit testing. So if we do this now, hopefully it's just going to pass the tests. Lovely. It's found 7 tests and it's run them successfully. The next thing it's going to do is it's going to try and deploy it. So by doing sudo docker-compose build, it's going to create those images. Let me just make that very clear. So sudo docker image ls. What I'm going to do is quickly just remove those images. We got this one, we got this one. Just going to get rid of all of these images just to really show you. Oh, can't delete the image because Okay, don't know what that's about. Okay, let's clear that. Sudo docker image list them. Should be able to delete those. Sudo docker container ls. Sudo docker image remove. Let's give it a nice little force. There we go. Now we're going to force remove this other one. Going to force remove this other image, and finally remove this image too. Sudo docker image ls. Hey, we got no images. What's going to happen when we do sudo docker build? Docker compose build, because we're going to be using that YAML, which tells us how to actually build it. Build within the client, build within the server, expose the ports inside those images. So sudo docker compose build. This time when we look at the image list, we can see that we have the two images which we're going to run, as well as the base images which they're built upon, because it just downloaded them locally, just for future use. Next, we're going to do, hey Docker, you know these images that you just downloaded, the ones you built? Run them, but run them detached, because, well, I don't really care about what you're doing. Just do it. Lovely. So now we've got our entire website working. If I go to, oh my goodness, where is it? If I just go to this IP address, here we go, and it's all working fine. That's due to the Docker Compose up. It's running the two images, which are my front end and back end. Now again, I don't have Apache local to this computer. It's not actually on this machine. If I were to cd var www/html, it's just not a thing, because Apache is installed within the container. So I don't need to worry about any permissions and stuff as well. Finally, inside this Jenkins pipeline, we're going to run some tests. Selenium tests, to be precise. And that is why we're going to say, hey, now run the Selenium suite, because we can't run the Selenium tests before it's actually running. So first thing I need to do is I actually need some kind of, I don't know if this will actually work. I'm going to see. Maven test. And I want to run only that suite. So a suite is just a bunch of test cases, a bunch of test classes. And it's failed because it doesn't have Chrome installed. I mean, we have the binary, so we have the resource, the actual Chrome driver here. I know it's not really good practice to include the Chrome driver as part of your project just because it's a bulky file. You'd probably put it on the machine, but not part of the actual repository, and you just link people to how to download it. I did, just because it's going to be easier. So even though I have a Chrome driver, it's going to tell it how to talk to Chrome. I don't actually have Chrome itself. So let's download Chromium browser. That looks about right. Let's download the Chromium browser. Bing diddy dink. Oh, that's lovely. So what do I want to do now? Now I'm going to try run that command again. Maven test. I want to run the fudge nuggets. I want to run the Selenium suite, and this time I'm not at the right place. This time now I've actually got a Chrome browser installed, as well as the Chrome driver. It should just run the tests. He said hopingly. It's taking its time. Oh, and it's gonna fail. Do you know what's gonna fail? No, it passed. It doesn't matter. It's passed. It's fine. Don't worry about it. So it's actually run all three tests and it's passed. Why? Because we've actually said as part of the tests within this test folder, within java.com.qa, within the Selenium suite, which is actually going to run through create, then it's going to run through update, then it's going to run through delete. What we've told it to do, let's just use one of these. This is just awful practice, by the way, but got it working. We've actually told it to run it headless, so it's not actually going to pop something to your screens. So what those 3 lines, and make sure it's not going to try and pop something up, which is going to be incredibly difficult when we don't even have a GUI on this operating system. Lovely. So what has happened there? We've managed to go from forward to backwards, updating it all. I need to run all those commands automatically all the time. Keep going, install it with our tests. Run this test suite, build it up, and then run this test suite. Now, as I'm building this, I might need to include another stage. Maybe I need to include another microservice. Maybe I need to include another thing. So that's why I've put it as part of the actual commits. Because what Jenkins is going to do now, inside here, it's going to look in developer for a file called Jenkinsfile, and actually use that as a way of building the Jenkins pipeline. So if we were to save this now and build this, just realize that is going to fail because I haven't allowed sudo permissions. And we have a pipeline being built. It's not going to like the build step. No, that's the line. It will go fine with JUnit tests as well, but it will fail at the deployment stage. The reason it's going to fail, let's have a look. Yeah, you download things, I understand. When I ran the sudo docker, it said no TTY present, which is basically for, if you look it up, it just doesn't have the correct permissions. So if I look at the users who can use sudo, I'm just going to add Jenkins. Now it would be better practice to actually allow anyone using Docker to not need sudo. I'm just doing it here because it's going to be it's going to take it a little bit longer. However, you can look up how to do that yourselves. When I did that, I've just said Jenkins allow everything. It doesn't need a password for anything. So that way, when we run this again, it's going to compile it into the jar. That's my build step. It roughly takes around 11 seconds to do that. This time only 7. It's going to run the JUnit tests. It's then going to deploy it. Oh, why did that fail this time? Oh, it's because there's a different user running the account. It's a different user trying to run the container. So it's basically 2 different containers trying to use the same port and port forward. So what I'm going to need to do is sudo docker container ls, list all the containers in use, and I'm just going to kill them off. Sudo docker container kill number 1, and let's kill number 2. Right, hopefully this time it's just going to work. Would you look at that? It's deployed, it's running the Selenium tests on it. Why have you failed? Doodly-doo. So we don't actually create one. So what I'm going to do, I'm going to go to I'm just going to build that again. Hopefully it runs it. Selenium. You worked before. There's no reason why you shouldn't work now. Oh my goodness. That is unfortunate. There's nothing actually there though, mate. What are you talking about? Alright. So what's happening is, in my thing, because I got loading set up, it adds an image, it adds something, is expecting there to be 2 there, but because there's only 1, it's failing and then not going to the other things. So that just means I need to briefly change my Selenium tests. But the actual pipeline is working just fine, and it tells me I need to alter my Selenium tests. What it is doing, it is automatically getting this far through the pipeline, and then when things fail, what we can do is say, okay, well when this fails, do the following, email this person, or do this, or do that. Now, if the thought of doing this Jenkins pipeline scares you, well, there's other ways you can do it. So I'm just going to kill off the containers. You can just stick to, let's run another one now. We can just stick to our freestyle project, which you know and love. Oh, okay. Oh my goodness. So rather than have this part of the commit, we can just put everything in here. Be 15 minutes. I'm going to build it like so. I'm just going to take all these items. I'm going to cd into server. I'm then going to run this. I'm then going to run. So I'm going to install it so we can get that jar file. We're going to run it only with that test. I'm going to go back up to the parent, sudo docker-compose, sudo docker-compose up -d. And then I'm going to leave off these Selenium tests just for now, just because it's failing annoyingly, just as I try to demo it for you. So if I build this now just with the freestyle project, it's going to do the exact same steps it did before. So before, this website shouldn't be working because I cut off those containers. Why are you failing? Oh, do you know why it's failing? Because I'm looking at master. Really? I need to be looking at developer. Let's build that again. Hopefully we should get a bit more out of it this time. Hey, we can see it's building the jar. It's then running the tests, those JUnit tests. And they all seem to be looking good there. Run 7. It's building those Docker images and then running them. Blah 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 blah. There you go, doodly doo, doodly dee. So you can use both. Don't really worry about that. I just like using the pipelines because you can actually see it being built step by step, and it just gives you a bit more pretty readout. Right, so that is how you can use Docker. This is how you can use Jenkins. This is how you can use Selenium and JUnit tests. Hopefully this helps.